Hey students, this is lesson 12.4, box and whisker plots. In this lesson we're going to learn how to make and interpret box and whisker plots and to find quartiles and percentiles. Go ahead and do the vocab and review. Pay close attention to what a quartile is and also to what the interquartile range is. I'll check back with you. All right, first thing we're going to talk about is what we call a 5-number summary of a data set. And a 5-number summary includes these parts: the minimum, the first quartile, we just abbreviate that Q1, the median, the third quartile, and the maximum. So to get those values, we're going to put these numbers in order from least to greatest. You can go ahead and do that and pause. All right, now that they're from in least to greatest, we can tell the minimum is just the lowest value, so that's 12. The maximum is the highest value, that's 40. The median, I believe you know how to find that, but all we do is cross out the first and last until we get the number in the middle. In that case, it's 20. Now, the first quartile is the median of the first half of the data, and we split that data in half by the median, so I'm just going to look at these three for the first quartile and these three for the third quartile. And then I just take the one in the middle, the median of the first half, which is 15, and the median of the second half of the data, which is 27. All right, go ahead, you try that. All right, a box and whisker plot is a graph that uses the 5-number summary and displays it on a number line. It has 3 parts: a box and 2 whiskers. The whiskers represent kind of the extreme values, and the box represents the more normal set of the data. All right, we're going to go ahead and make one of those here. First thing we need to do is put these numbers in order from least to greatest and find the 5-number summary. All right, now that I have my 5-number summary, I have the values I need from these. I have my minimum, my maximum, the number in the middle is the median. The middle of the first half of the data is right here, which would be 32.5. And that's my first quartile. And the middle of the top half of the data is right here at 37, and that's my third quartile. Now that I have all those, I'm going to create the box and whisker plot on a number line. So here's my number line, and I need numbers that go from 30 to 40. So these are the values I chose. So I have 24, 28, 32, 36, and 40. And then what we're going to do is put a dot, estimate where each of these 5-number summary values will be on the number line. So 30 will be halfway between 28 and 32. 32 and a half will be a little bit above 32. 34, halfway between 32 and 36, 37, one above 36, and then 40 is at the maximum. And then we're going to draw in our whiskers, which are between the third quartiles and minimum, or the maximum and the first quartile. and the minimum. Then we're going to draw a box between the first and third quartiles, and we'll draw a line at the median there. And you can even label these with the numbers now. So we have 30 here for our minimum. We have 32.5 for our first quartile, 34 for our median, 37 is our third quartile, and 40 is our maximum. All right, go ahead, you try that. All right, once we have box and whisker plots, we can use them to interpret differences in data sets. In this case, we're looking at two different species of snakes, and it says, first question says, which species of snake has a greater range? And the range is reflected by the length of the entire plot. So whichever plot has a longer length, that would be a greater range, and that would be species A. And then the second question says, which species has a greater interquartile range? And that would be represented by the length of the box. So this length here. And you can see species B has a greater length of box. I'll write down and summarize what I just said there. Now, what we want to think about here is, what does it mean to have a greater range? And one thing that often you might want to look for is which species of snakes have more varying lengths. And you could use the range to represent that, but oftentimes the interquartile range is used instead. Now, the interquartile range means the middle 50% of the data, which is really the more normal part of the data. And a bigger box, as represented here in this one, means that you're going to have more different lengths in that species of snake. Notice that most of the snakes here range in a smaller area. All right, go ahead, you try that. All right, the last thing we're going to talk about here is the percentile range. And one thing a box and whisker does is it separates things in percentile ranks because it's splitting up the data. So if you look back here at Miami here, this little part of the data, since that's 1/4 of the data, right there is the 25th percentile. The median is the first half of the data, so that's the 50th percentile. The third quartile is the 75th percentile. So it splits it up nicely into percentiles. Now, to find a percentile, what you need to do, the percentile rank of data is the percentage of data values that are less than or equal to that value. So if you say you're in the 80th percentile of, say, your height, that means that 80% of people are shorter than you, so, or equal to you. So here it says that of 40 students, 9 are taller than 5'10". What is the percentile height of 5'10"? What we really want to know is what percentage of values are less than or equal to that value. So what percentage are less than or equal to 5'10" inches? Since 9 are taller, that means that 31 are less than or equal to out of 40. And if we change that to a percent, if we divide those two numbers, we get 0.775, which changing it to a percent is 77.5%. So in this case, a person that's 5'10" is in the 77.5 percentile. So answer D. Go ahead, you try that. All right, that brings us up to the lesson check. Go ahead and try that, and we'll talk about that next time we meet in class.